All right, everybody, welcome to the Regents Review video number 4. So in this video, our concept here is starting to talk about the unit circle. So we got to get tricky with it today. So for these problems, we need to understand really what the unit circle is, how it works, and how all these trigonometric ratios kind of work together in ways. So let's just jump into it. So the first question says a circle centered at the origin with a radius of 10. The terminal side of an angle theta intercepts a circle in quadrant 2 at point C. The y-coordinate of point C is 8. What is the value of cosine? So first things first, it's multiple choice. So some are negative, some are positive answers. Knowing what quadrant we're in is huge. So because we're in quadrant 2, we know because all are positive, sine is positive, tangent's positive, cosine's positive. And if I'm over here in quadrant 2, that means cosine's negative. So it actually cannot be choice C or D without doing any work other than just knowing that part of the unit circle. So for these questions, the best thing to do is actually draw a little picture. So I'm going to draw a quadrant 2 angle. So I really don't care about the other quadrants too much. So angles always start here on the positive x-axis and are going to rotate around in a positive way to terminate somewhere here in quadrant 2. And this point, we're going to call point C. That point is on this huge circle that goes around this whole thing. And on that huge circle that has a radius of 10, this point can drop vertically down to make a right triangle. And the y-coordinate of this point is 8. So the vertical side of this little triangle we just made is 8. I'm interested in this side. Because if I make this angle theta, that makes this little angle in here the reference angle, and I could just use my regular SOHCAHTOA rules to figure out what cosine is. So since we have a right triangle and we know two of the sides, we could use our good friend Pythagorean theorem. So I could say one side squared plus the other side squared equals the hypotenuse squared. And we could go ahead and start doing some ninth grade algebra and figure out what x is. And we get x equals 6. So we know this other side here, I'll even erase the x and replace it with 6. Now, since we're talking about this reference angle, the opposite side is 8, the hypotenuse we know is 10, and the adjacent side we now know is 6. So if I want to find cosine, cosine is the adjacent over the hypotenuse, so it'd be 6 over 10. So the cosine of theta is 6 over 10, which reduces to 3 over 5. But because we're in quadrant 2, we know it's negative 3 over 5. All right, let's take a look at number 2. Number 2 gives us the Pythagorean identity here of sine squared plus cosine squared equals 1, which I know for me, we didn't use too much in class because most of the questions that are on the Regents exam, if not all of them, can be answered just using SOHCAHTOA and understanding how the unit circle actually works. This identity is great, it's useful, it can be used to answer this question, but it's actually not needed at all to get this value that they're looking for. So it tells us that sine is negative square root of 2 over 5. And it says, what is a possible value of cosine? Well, if you look at all your choices, they're all positive. So again, going back to all, sine, tangent, cosine, what quadrant are we going to be in if sine is negative and cosine's positive? Well, that would be quadrant 4. So I'm just going to go ahead and draw a quadrant 4 triangle. So if we make a triangle that comes out of the origin, always drops to the x-axis, and I'll just make this theta come around like this, making this the reference angle that we're using to do all of our SOHCAHTOA stuff. So because we know the sine is opposite over hypotenuse, So I know the opposite is square root of 2, and the hypotenuse is 5. So again, just like that first question, I need to find the missing side. So I'm going to say side squared plus the other side squared is equal to the hypotenuse squared. So if we square a square root of 2, it just becomes 2 equals 25 minus 2. And we get x squared equals 23, or the square root of 23 is that missing side. So we can put that back in there. So now again, if we use SOHCAHTOA, we're talking about cosine because that's what they want. It's the adjacent over the hypotenuse. Well, if we're talking about this reference angle, the adjacent is here, the opposite is here, and the hypotenuse is 5. So we're talking about the square root of 23 over 5. Again, I didn't need this at all. Number 3 is actually a pretty straightforward question if you know a couple rules. So anytime that it says that a point is on the unit circle, intersects the unit circle, is on the unit circle, we already know two things about this triangle that's created. We know that the x value is the cosine, and we know that the y value is the sine. Now, knowing that's important, because if I want to find secant, we have to remember that the secant of theta is equal to 1 over the cosine of theta, or the reciprocal of cosine. So if we know that the cosine of theta is equal to negative 1 over 3, that means the secant of theta is going to be negative 3 over 1, the reciprocal. So this answer is just negative 3. Now, since we're talking reciprocals, we might as well go over the other ones. So secant has a reciprocal of cosine. Cosecant is the reciprocal of sine. And cotangent is the reciprocal of tangent, which is also cosine over sine. So if this was the same exact question, all of the same exact information, but asked you to find the cosecant, we would have taken the reciprocal of square root of 8 over 3. And that would become choice B. If this said cotangent, we'd have to do more math, but now we've at least seen all of the reciprocals. Number 4 is basically the same question. It's just not multiple choice. So we have this identity again here. We can use it if we want. I'll even show you how to use it for this one. Or we could just use right triangle trig. Right triangle trig always works. So it tells us that the cosine is negative 0.7, which is a little bit weird. Because we like fractions, I want to know what the opposite, adjacent, hypotenuse is in my trigonometric ratio. So I'm going to rewrite this as the cosine of theta is equal to negative 7/10. And we know it's in quadrant 2, so let's draw a quadrant 2 angle. So here's our angle coming around, terminating somewhere in quadrant 2, and we'll drop down our right triangle. So theta is over here, reference angle's in here. So if we're talking about cosine, that's the adjacent side over the hypotenuse. And again, I could go ahead and find the missing side. So I could say side squared plus the other side squared equals 10 squared, the hypotenuse squared. And I can get x squared plus 49 equals 100 and do some quick algebra here to get that missing side, which is the square root of 51. Now they want us to find tangent. Tangent, remember, is TOA. So if I look at this reference angle here, the opposite side is the square root of 51. The adjacent side is 7 and the hypotenuse is 10. Well, if I want tangent, I want opposite and adjacent. So I'm going to say the tangent of theta is equal to, we're in quadrant 2. We know that in quadrant 2, only sine is positive. So tangent must be negative. And it's going to be the square root of 51 over 7. Now, this does give you an added trick here. This can trip you up. Square root of 51 over 7 is a perfect answer, but it's not in the form they want. They want you to make an approximation here rounded to the nearest hundredth. So we got to go to Desmos. Let's open up a tab here. And we have to type in our square root of 51 divided by 7. So we get 1.02. Don't forget the negative. That's the answer they want. Now, say you wanted to do this using the identity. So using the identity, what they want you to do is to replace cosine with negative 0.7. So you'd say sine squared of theta plus negative 0.7 squared equals 1. And now if you solve for sine, you then can use sine and cosine to find tangent. And you'll actually see it's going to come out to be the same ratio when it's all said and done. So we'll say sine squared of theta plus negative 0.7 squared. So negatives go in parentheses. And we get 0.49. If I subtract 0.49, I get that the sine squared of theta is equal to 0.51. Hey, look at that. Same number, just a decimal version of it. Square root both sides, and we get that the sine of theta is equal to the square root of 0.51. Now, if you know sine and you know cosine, you can find tangent pretty easily. So tangent's ratio, remember, is sine over cosine. That's our rule for tangent. So if I want to find the tangent of theta, I would say it's negative because of what quadrant we're in. And it's going to be the square root of 0.51 divided by 0.7, the sine value over the cosine value, which if you type into the calculator is going to give you, guess what? The same exact answer. Number 5. Number 5 says that we have an angle in standard position. Its terminal side passes through the point 2, negative 1. If I go to the right 2 and down 1, I am in quadrant 4. So I'm going to draw a quadrant 4 angle. Here is the point. This is the point 2, negative 1. Terrible picture, but it's okay. So we have a right angle. We're starting at 0, 0, and we're going to the right 2. That length is 2. And then down 1. That length is 1. So we can say 1 squared plus 2 squared equals this missing side squared, the hypotenuse squared. 1 plus 4 equals x squared. And last time I checked, 1 plus 4 is 5. So we get the square root of 5 is equal to that missing side. Now they want to find the exact value of sine. So if we're talking about a quadrant 4 angle, theta wraps all the way around to quadrant 4, and the reference angle's in here. So this is the opposite side, this is the hypotenuse side, this is the adjacent side. Well, if we're talking about sine, that's so. And we know in quadrant 4, all students take calculus. In quadrant 4, sine is negative, so we know that the sine value of this angle that terminates in quadrant 4 is a negative number. We know it's the opposite side over the hypotenuse side, which is the square root of 5. This is our exact answer. Number 6 is a great question. If you can answer number 6, you truly have a good understanding of the unit circle and your regular right triangle trig stuff for this course. So it tells us that we have a point located in the second quadrant, and again, it tells us it's on the unit circle. So by saying those words, we already know something about this triangle that we're trying to create. We know that this y value represents the sine of theta. So it's basically like they're telling you the sine value without specifically telling you the sine value. We also know, because we're in the second quadrant, you are going to have a negative t value. T must be negative in the second quadrant. Graph a point in the second quadrant, the x value has to be negative. Also, we know that the t value is represented by cosine, and the cosine in quadrant 2 is also, you guessed it, negative. So if we draw a triangle in quadrant 2, sine is the opposite, so we'll label the opposite of this reference angle here. And the hypotenuse, so that would be the hypotenuse. And again, for like the 5th or 6th time, let's use Pythagorean theorem. The side we don't know squared plus 4 squared equals the hypotenuse squared. And we could go ahead and solve this one. And we get x squared equals 33, or the square root of 33. That's our missing side. All right, so I want to find the value of t. And we know that the value of t is actually cosine, because the x value of a point on the unit circle is cosine. So we need to use ka. So the adjacent side, if we label this up, right, this is the adjacent, this is the opposite, and this is the hypotenuse. So the adjacent side is the square root of 33. The hypotenuse is 7. So we could say that this t value is a negative number because it's in quadrant 2. And it's the adjacent side square root of 33 over the hypotenuse side, which is 7. And that's it. Hopefully that helped you understand the unit circle and some right triangle trig a little bit better. Make sure that you're practicing and you are ready for your weekly quiz.